I wanted to just give a quick intro for a minute or two about Hyperledger. The Hyperledger Foundation is an open global ecosystem for enterprise-grade technologies. They have an umbrella of projects that enterprises are using globally. Kaleido is helping host this meetup event. We are an enterprise-grade Web3 platform working with leading companies driving blockchain, digital assets, and NFT projects. We're also very active in driving one of Hyperledger's fastest growing communities over the last 2 years in the Web3 space called Hyperledger Firefly. And one of the maintainers is right here today, Nico, if you'd want to talk to him after the speakers' lightning talks. So we're pretty privileged here in the RTP area to have some true global leaders amongst us. And it was a lot of fun to pull this meetup group together. So I'll just briefly describe the backgrounds of the 4 speakers, and then I'll pass it over to the first speaker. So Jerry Cuomo, who's standing to my right, is the father of blockchain and Web3 at IBM and an IBM fellow, which is the highest technical honor you can achieve at IBM, plus super nice person who gives back to the community and is actually teaching a course on Web3 at NC State, which was the genesis of his book, Think Blockchain. So his latest book, so feel free to talk to him about it. And I think we have some copies around here that Madison has in the back. And then joining us from academia is Campbell Harvey, who is professor of finance at Duke University, a true global leader on DeFi and looking at the future of finance. So he actually is involved. Duke has a really great digital assets conference that they do. They pull in a lot of global leaders as well. I know he's active in a lot of the efforts, both on campus and beyond. So we have a technologist for technology vendor, leading technologist, someone leading in the academic space. We also are very privileged to have someone who's leading and can provide the enterprise perspective of actually affecting transformation and change within companies. So she's a P&L leader for next-gen retirement products at Fidelity, workplace investing, and has really done quite a bit in the space and a lot of learnings to share and best practices and insights. So we're really excited about that. It's Sterling Ingui. And then our last lightning talk speaker is Jim Zhang, our very own Jim Zhang from the Kaleido team. World-renowned protocol expert, is familiar and been an active contributor to all the major enterprise blockchain protocols. So we're very blessed to have him on our team. And he's had a busy day because he was just talking to the SEC earlier. So he's, and weaving in lots of different interesting conversations in the industry. So with that, again, just because we have the couple hundred people dialing and live streaming, if anyone does want to talk, just, there's some breakout rooms, or you could step outside for a few minutes to do that so we get good audio for everyone on the live streaming. With that, I'm going to hand it over to Jerry Cuomo.
Thanks, Sophia. And you have a real rock star in Sophia Lopez here, one of the co-founders of Kaleido, probably the dominant up-and-coming blockchain cloud in the world. So Sophia, thanks for having us here. So hey everyone, I'm Jerry Cuomo from IBM, and I'm going to talk to you for 10 minutes or maybe 8 minutes and ask my friend Mark maybe to speak for a minute about Think Blockchain. So I'm going to share with you my excitement about blockchain through this book project called Think Blockchain. So first of all, Think Blockchain. So if all of you know, the IBM slogan is Think. So you wouldn't be wrong to make that connection. As Sophia said, I had the privilege of running the blockchain technology group for about 6 years since its inception. I had the great pleasure with John Wolpert back there being one of the early instigators with about, 15 other companies to help launch under the Linux Foundation, the Hyperledger project. So, amazing times over the last couple of years. But this book is a little different in that it's a student's guide to blockchain. So I had a chance to step back and reflect on the 6 years. And I put myself in a mental place of standing in front of a group of students, and students need not be undergraduates or graduates, as anyone who's curious about blockchain is a student in my definition. And the first thing I said is, I've been put into the corner that I placed myself and IBM in enterprise blockchain. So the first thing I had to do before I can credibly get up in front is I had to immerse myself in the full world of blockchain. So as a student's guide, one of the things I needed to do, and kind of like say, shame on you, Jerry, for not doing this on day one, but I really got under the covers of Bitcoin and Ethereum to really study those so I can give a fair and unbiased representation of the space. So when I say a student guide of blockchain's evolution, which is still very much going from Bitcoin, Ethereum, Hyperledger, to a future state of the internet, Web3. That's what the book is about. And so I do, like, there's quizzes at the end of chapters and stuff like that. So I do take on that stature. And in last year in the fall, I taught cybersecurity blockchain, and that was the textbook year. So it's like a dream come true. And I tell you folks, it was the thrill of my life and also equally terrifying to stand in front of 35 students for 16 classes where they were bright as the stars with laptops open in hand, fact-checking everything I said. So that's that. So Jerry, and by the way, I've never given a talk with an easel, but I had to do a first here. So I'll pass this around in a second. So I said we're going to go over a couple key takeaways. The first takeaway for the studio audience at home is a definition of blockchain. Everywhere I go, we jump into blockchain, and there is kind of a gravitational pull that comes with blockchain toward cryptocurrency. And that is what it is. Few applications have that tight association as blockchain does. And I think for many part, it puts it on the map. But I think at another level, it undersells what it is and what it does. Blockchain is a technology, right? So in the book, in a very quirky way, you see the cover of the book is a duck. And I had this duck thing going on. So I said, if databases were birds, then blockchain would be a duck. And I start off with the students, kind of to warm them up to the topic. Not that I believe blockchain is a database. Oh, far from it. It is a wonder of architecture that brings, generations of work in cryptography, distributed computing, and database technology to the forefront. But I like to anchor things in a place that people know. So it's a fair place. You wouldn't be right to say blockchain was a database, but you wouldn't be completely wrong either. So that's how I start off the class, and read the book for the full definition. But it also then triggers a whole bird fetish in the book. But I think one of the interesting points that I try to make throughout the book and build up is that Bitcoin is just one application. And if there are 1,000 applications, it would just be one. And while I have little against cryptocurrency, my interest is predominantly in the other 999 applications and really letting people's imagination loose. And folks, in my 6 or 7 years, maybe more now, I'm probably not counting right anymore, but I've seen some amazing things, and I'm going to share some of those with you. You can pass this around if you'd like. The key part, what attracts me to blockchain, the secret sauce that I see that it does, that few things do, is around trust. And folks, trust between humans built through reputation will never go away. It's a fundamental part of society. But you sprinkle in a little cryptography and distributed computing, and now you have algorithmic trust. And the two pair very well together. And with those, you can do some amazing things. So when I think about trust, and you're going to hear ChatGPT come up a few times, why, it's 2023, that's the rage, and everyone's talking about, thinking about trusting AI. So in this story that I tell in one of the chapters, you go to a doctor because they're as hooked on technology as you are, and your doctor has the AI assistant that helps, diagnose and prescribe drugs. So you go in there and say, doc, I have a back pain. Can you help me? And the doc assistant advises your doc to prescribe you Big Pharma's back pain relief capsules. Sounds right. Your doctor can't possibly, it's only human. She can only read so many periodicals and they're coming out every week, every month. She's busy. She has a very healthy practice. But with AI doc, she pinpoints the problem, the right drug, there you go. And then later on, you get some blood pressure problems. And then lo and behold, AI doc, recommends Big Pharma's hypertension pills. And being a little skeptical, you start to say, who trained this model? Who created the model? Where did the training data come from? Could it have been Big Pharma? Why should you trust AI, right? How could you? Explain to me where this came from. I want to see it like a food label. I want to be able to go back and see what the ingredients are, what the provenance is. So blockchain and AI, for this case, pair very well. We talk about that in the book, that blockchain is at the nexus of new technologies. And what it does, by bringing trust to these technologies, like explainability in this AI sense, increases adoption, right? Gets rid of the skeptics. Again, nothing wrong. Big Pharma may have been around 100 years and has a great reputation, right? Reputational trust, but then you sprinkle in a little algorithmic trust and it goes a long way, right? So that is one of the takeaways around blockchain building trust. All right, which lets us get, and I'll pass this around. With trust, blockchain could build and create an environment where everyday life can change for the better. And this is what excites me. I've been around technology a long time. And when I can go home and tell my family and friends that we're actually doing something, not just because it's cool tech, but we're changing everyday life for the better. And I have two examples. I don't expect you to read these charts, but one example is, would you believe me if I said blockchain is well on its way to being an ingredient to help preventing foodborne illnesses and food waste, right? E. coli breakouts, we see them all the time, right? So with the Food Trust Network, we're seeing companies like Carrefour, which is kind of like a 7-Eleven in Europe. They have QR codes now on their food, and a famous piece of food that they have it on is a box of dried potatoes. You can scan with your mobile app the dried potatoes, and then you can see kind of the provenance, where this box was. Where did the potatoes come from? Right down to the farm. So farm to shelf, right? You can actually track that. And so we talked about earlier, for AI having a food label. Well, this really gives you a label that shows you farm to fork. Walmart did an experiment that took 2 weeks to track manually a bag of sliced mangoes from one of its stores to the source, to the farm, the mango farm. With the Food Trust Network, 2.2 seconds, right? That's a big deal, right? That's changing everyday life for the better. The same thing, and for the lack of time, I'll just cut it really short, but in New York, during the pandemic, there was the Excelsior Pass, right? Which allowed you, which was a digital form of your identity and proof of vaccination, right? And that was put on a blockchain. When you think about the complex ecosystem that needed access to that data, right? Think about your healthcare provider, Walgreens, the airport, right? The airline, right? Those are some really diverse organizations, right? Putting that information on a neutral zone, right? Staying GDPR compliant and being able to prove that you were vaccinated, really streamlined processes, from days to seconds, right? That's a big deal. I hope you agree that's blockchain changing everyday life. And in the end, you start to see that these ingredients in blockchain can really start to take a run because of its natural resistance through cryptography for even things like preventing cyber attacks, right? So doing things like decentralized DNS decentralized storage, and you start to see these problems. So we talk about that in the book. I got one more here, and that's about Web3. So I start my chapter on Web3 about Web3 is the future of the internet fueled by blockchain. And I go to a very modern example. I go to 1890, the introduction of the Players League. So picture this, Major League Baseball is 10 years old, and already the players and the owners are at each other's throats. They still are at each other's throats. Why? Well, the players feel that they're not getting their share of the profits, and they have no control in negotiation, right? I think we're seeing this in the internet. Like, people say Web3 is addressing things that are new, that are driven by our new digital economies. Maybe true, but I think what we've been seeing in arts and entertainment, that kind of shift of balance every once in a while, the creators, in this case, the players that hit the home runs, that put the fans in the stands, want a seat at the table, both financially and also from a control perspective. In Web3, people want that same control. You're creating the data. That's your thermostat data from Nest. You don't mind sharing it, but if Google's going to sell it to Duke Power, give me a little cut. That's my coin, right? And you want to give me something back of value, benchmark me against my energy use against my neighbors. I may pay for that. You can do new offerings on that, right? But give me a little control and give me a little reward from that. So the fundamental premise of Web3, we've seen it. It's new, but it's also this kind of balance, this labor balance that we've seen. And we can learn a lot from that. And we talk about that in the book. And I end with where I started, which is Pete's poems, NFT. So the class, blockchain class, ended with an assignment. All 35 students, I asked them to kind of put it all together and create an NFT that demonstrated a few things. And one of the ones that really captured, my emotion was Pete's poems. Anna, one of the students, undergraduate students, she has a dog that she found on campus called Pete, and she fell in love with Pete. She was supposed to bring it to the ASPCA, but she wound up keeping it, fell in love with it. And what she did is she created an NFT out of Pete's pictures, and this is Pumpkin Pete, and then pairing it with ChatGPT, a poem that ChatGPT represents and explains the picture in a poem. You got to check them out. It's pretty inspiring and pretty creative. I actually couldn't resist. I bought Ice Cream Pete, which is Pete's head impaled in a bowl of ice cream. So it comes around that when you empower students, with a new technology, and you position it for good, and you bring an element of reputational trust, which has been around for generations, pair it with some computer science, some algorithms, cryptography, decentralized computing, you create a new trust model that can change everyday life for good. Hope you're encouraged. I'm inspired by this. Hope you're inspired. Now, my friend, Mark Parsonet, he's standing in the back, very tall guy. He will talk to you at the break and tell you about the chapter he contributed to the book called I'm Satoshi. And you really want to hear the story. So, Mark, say hello to everyone. All right. Sorry, Mark, I ran out of time. Usual thing. I cut you short. Next.
basically put there essentially for free. And who makes the money? Well, the platforms. So the users are not customers. The advertisers are the customers. So in Web3, what we do is change the model so that the users actually can be paid and get paid. And actually, this is a significant innovation. It's made possible with decentralized finance. There's no Web3 without decentralized finance. So I'm going to give a simple example of how crypto kind of works, and then I'll give a few other applications. So an example I usually use to motivate with my students is ticketing. And ticketing is in the news, people complaining. They've been complaining for a long time, but we kind of know how it works. Maybe you don't know exactly the extent of how it works, but Ticketmaster gets 40% of what you pay. And that's a pretty big hit, but that's not the whole story. They do something else that's really costly. And that is they put a wedge between the artist and the fan. So the fan has got a relationship with Ticketmaster. Okay, so what about using kind of a crypto backbone? And that kind of makes sense. It's an obvious application of non-fungible tokens or NFTs. So NFT is a unique token. So the unique token is the event, the venue, the date, the seat. And the user experience is pretty similar to actually having a digital ticket on your smartphone. Okay, so it is, when you do that, then the 40% is obviously reduced. You've got some other features in that if the ticket is resold, then you can build into the NFT a royalty. So on the resale of the ticket, the artist and venue, let's say, get 10%. So that's attractive. And then, of course, you could use the NFT maybe to get discounts on gear and stuff like that. But importantly, once we've got this NFT community, the artist can interact directly with the fans. Okay, you create this community that wasn't possible before. So the artist could perhaps mention the next concert, might be a nearby town. The artist perhaps can airdrop some new song. So this makes a lot of sense to use blockchain technology for this particular application. And this is just a straight use of blockchain technology. So I want to emphasize that it's not just about getting a bigger share of the revenue. It's about the ability to build a community. And that's the whole idea of peer-to-peer. So you take the middle person out, which is Ticketmaster, and you can create that community. So this is a straight application of blockchain. It's not a Web3 application yet. So let me turn it into a Web3 application. The first 1,000 people that buy tickets to the concert get equity in the concert. So that is kind of interesting because it changes their behavior. So they've got the seat to the concert, which they would usually have with a straight NFT or buying a ticket via Ticketmaster. But now, if the concert does well, they get a payoff. They're investors in the concert. Their behavior changes. So now they're much more likely to promote the concert on their social media, tell their friends. And this is the essence of Web3. When you're involved in Web3, you're an investor in the platform. Okay, and that's, I think, a big idea. So it's almost as if in traditional finance, you go buy like a phone in like the Apple store, and they hand you some stock. Okay, so let's think about this. And I know that crypto and stuff like this is in the news. Most of it is just noise, in my opinion. Centralized firms trying to make a quick buck and bending the law or breaking the law. But what I focus on in my teaching is what the world is going to look like in the next 10 years. Not what's happened in the last year or even what will happen in the next year. So if we think about what this idea could portend, it is very significant. And you go through the list of possible applications here. So you think of decentralized search, decentralized social media, where if you put content up, you get paid in a platform token. Okay. If you choose to put your data up, you get paid for it. If you choose to view an ad, you get paid for it. This completely changes the experience. Okay, so I tell my students that Google could make up to $10,000 a year off of them. Okay, so this is not a small amount of money. So this is one application, but it goes on and on. So it could be, for example, decentralized video streaming, decentralized music streaming, decentralized Wi-Fi, long-fi. So basically you join the network, you buy, like a 5G repeater, and you're in the game. And everything is done with the platform token. The platform token enables the buying of the Wi-Fi and the revenue from the Wi-Fi. And it's not just this. We could do the same thing with mobile communication. And then there's other obvious applications of this technology. So think about computing. Think about how much of the CPU that you use every day on your desktop computer. Maybe like an hour, 2 hours. So what about a system whereby you can rent that out and you get paid in a platform token? And there's a massive amount of computing out there that is just unused. And this technology makes it possible. Or file storage. So we've got cloud providers, but we also have a vast amount of unused storage. So my computer might have, let's say, a half a terabyte that I'm not using. Well, why not get paid for it with decentralized storage? So there's many other examples that I could go through. The next time you're in an Uber, ask the driver what they think about Uber, and you'll get an earful. Oh, they take 40%. The 40% number comes up a lot. So Uber is an algorithm, matching people. It is an obvious application of decentralized technology. So on the Uber thing, I want to mention one important thing. And that is that I'm not suggesting we're going to like a 100% decentralized world. There are certain things that are best done in a centralized manner, at least in the short term. So what we're really talking about is reducing the size of the middle layer. So for the Uber Lyft example, there's still a need for some centralization to certify drivers, to do insurance for the cars. So with Web3, with DeFi, what we actually do is to reduce the size of the middle layer. And this reduces transactions costs. It makes the experience much better for almost all of us, except for the people in the middle. So they're the losers in the short term, but they should be redeployed to more productive things. So this idea, again, the news, the mainstream media talks about the trials and tribulations of Sam Bankman-Fried or Elon Musk tweeting about Dogecoin. There's something else that's very significant in the background. All of the applications that I mentioned in terms of decentralized, there are many firms already in this space. So this isn't just an idea. There are firms in there actively right now. And if you think about this deeply, in some of my presentations, I do have a slide, and the final slide is a giant bullseye. And just think about the names that I didn't mention today in these spaces: mobile communications, computing, storage, streaming, social media. Those are the big firms today. And they got a bullseye painted on their forehead. So again, what I want you to think about is the stuff that's not necessarily in the news, but the stuff that's under the radar. That's where the big opportunity is. And I see a fundamental and structural shift that's possible for our economy with this technology. And finally, as with any new technology, it's not without risk. There will be risk events, and some of them will be severe. But that's the nature of innovation. And we've seen this throughout history. If you don't want to take that risk, fine, invest in treasury bills.
Thank you, Jen. So I'm Sterling Ingui, as Sophia announced before, and I'm here to give a different perspective. So you've heard from thought leaders in technology and in academia, and I'm here to share some business perspectives, a little bit about the business of blockchain. As Sophia mentioned, I work at Fidelity. I'm a product lead in our workplace investing, as well as North Carolina regional site lead. So very excited to have this great community in North Carolina focused around a technology that I think is incredible. And I want to share a little bit about what we've seen from our perspective and what we've learned at Fidelity. We really have a long history of innovation. Our innovation comes and helps us grow through market volatility. It helps us look through and grow through industry disruption, regulatory changes, and shifting consumer interest and demand. With that, we have, of course, large-scale technology platforms, and we have growing digital asset products and service across our businesses. So it's a digital experience, but we also have now a really long kind of growing focus in digital assets and blockchain itself. And this started back in 2014. In fact, we have some great friends here and leaders in Fidelity who've been a part of that, bringing it forward as part of Fidelity's way to learn through technology with research and development. How does this apply to us today and tomorrow? Where are our customers' needs and interests? And what are the business problems that we can solve? So what we've learned over time is that there are really three things that need to be true when you're looking at the business of blockchain and enterprise adoption. There needs to be that strategic alignment, right? You need to be solving a business problem, and it needs to be something that is of interest and of a need to your clients and your customers, whether they know it yet or not, but it can help them. And then there needs to be a way to really ensure you're leveraging the value of blockchain. You're not just doing blockchain because it's an emerging technology, but you're using it because the value of blockchain, that transparency, that ability to have more efficiencies really helps your business. And then you also really need to understand that interoperability, because we all have existing technology infrastructures, and we need to figure out how do we connect those processes, those systems with this emerging technology. And that's where I think when you have these three things come together, you can say, yes, let's move forward and let's bring this into a way that we can meet our clients and our customers' demand. So I mentioned that we've been looking at digital assets and blockchain for quite a while now. In fact, in 2014, we started this learning and understanding in our innovation group at Fidelity Center for Applied Technology and Fidelity Labs. And that's when I first learned about it as a product leader. So I was asked, Sterling, what do you know about Bitcoin? And I said, I don't know anything about Bitcoin. And I was promptly handed Bitcoin for the Befuddled. And so that was the book that I had to start my learning journey. And there wasn't the resources, the amount of 101s that were out there. We were really creating that, because what we quickly learned was that for us to understand the space, we would not only have to educate ourselves, our technologists, our business partners, our legal risk compliance teams. So that education started kind of within us, but then spread very quickly. And then it would also translate to how do we explain this to our clients and our customers. So for me, in 2014, I started reading Bitcoin for the Befuddled, and I was asked, what can you do or think about in bringing forward Bitcoin in a charitable manner? And so I have another friend in the audience here too, who worked on this with me. And we looked at how do we bring forward Bitcoin contributions for donor advised funds with Fidelity Charitable, and that launched in 2015. And that continues to bring a lot of opportunity today. Fidelity's journey looked at this holistically, though. That was my little portion of it. And over time, in 2018, we launched our Fidelity digital asset business, which does custody for institutions, and that continued to grow. And we've had more products and services expand because we look at it holistically. We really want to be thinking about who are those different clients and customers, what are their different needs, their risk tolerances, where are they in their different stages, that holistic perspective so that we can build out an ecosystem of offerings. I then moved into cybersecurity and looked at this from a very different perspective and supported our digital asset business. And that was one of the really important parts of when you're bringing forward this adoption in an enterprise. How are you working with your different partners, your legal risks, your compliance and security partners? How much do they understand? I mentioned education was critical, but how do we come up to speed and bring forward the best practices that we know of today in a world that is evolving and maturing? So that helped me understand a lot more on what it means to work with NYDFS and to attest to the cybersecurity of our custody solutions. From there, our company continued to expand, and I actually moved back to a product role, which is where I am today. And I brought forward our Bitcoin and retirement plans, opening up access, thinking about a way that we could meet that client interest and demand that was saying, we'd love to see a way that our participants who have retirement plans could have access and exposure to a digital asset such as Bitcoin. And with that client interest and demand, we looked at where we had our best practices, where we could bring forward capabilities, and that launched last year. Now I'm continuing that journey, and we're really looking at that blockchain as a business. And that's where I find it really incredibly interesting, where it is the technology that I think is fascinating. It's how we're getting into this shift from Web 2 to Web 3 and helping build the pipes and the rails that we can continue to evolve so that we learn by doing, that our technologists understand this space, that our security teams understand what it means to audit a smart contract, that we can understand that interoperability piece, that third piece. We have an incredible technology system. It works very well today. How do we capitalize on what is existing today, but bring forward that efficiency and that transparency that the blockchain can have and connect them? And that's where I've really enjoyed learning and partnering with Kaleido. They have helped me learn on my journey as well. And they're this blockchain as a service and this way to think about what is important for your company to do and what is important for others to do is something that everyone considers. And as you're on this learning journey, where can you learn from different parts of your company, your world, and what needs to get done on the blockchain and where you can kind of upskill that talent? So I mentioned before that there's a couple of things that you need. You need to have that strategic alignment. You really need to have that business problem that you're looking to solve. You need to have that value of blockchain come forward. So you're not just doing it to do and be in this technology, because there might be different ways and solutions to meet your needs. And then you need that interoperability. What made us successful, I feel, in bringing these three things forward, once we knew those three things were true, it was, okay, how do I get leadership support and an understanding. How do we get that education? Which is why I'm so glad to see that we have two great authors here with books, because we're always trying to learn and understand. And then how do we translate those learnings to all of our teams internally, and then bring that message forward externally so that people understand with the technology and they get beyond any fears of what the technology means or what the media is saying or how the ecosystem is evolving, and they learn how to work within that, and they can build to the regulations that are here today, and that we can bring things forward in a responsible way. I'll also say that the expertise and knowledge across so many different areas, like I love this meetup, I love how many different perspectives are coming forward, help all of us think about new use cases. So I encourage you to think about it. One of the ways that we brought these ideas forward to say what makes sense for our business was that we did an innovation challenge. And we said, okay, first of all, here's what blockchain is. Here's what makes a good use case. You need to have these answers, and you need to have the automation need. You need to have something where things need to be permanently on the blockchain. Think about what needs to be on chain, off chain, right? What really needs to be there. And then we said, what are your business problems? And we opened it up to people across our business. And we said to the business leaders, to the technologists, where are you having a problem? Now that you understand a little bit more about this blockchain technology, what makes sense? And we had 51 problem sets come through in this short amount of time. And then we took a team and we said, okay, who wants to learn more about this on the side? And who wants to understand this a little bit more? And we had so many developers raise their hand, and we had so many business partners raise their hand for what we call these kind of gig projects on the side of their work to start learning and say, okay, in 6 weeks, what is the problem? What could we scope out as a potential solution? And then it was pencils down. And we brought that forward and we said, okay, we gave you some resources and tools. We're here as your subject matter experts to bounce questions off of, and you're coming together, combining business and technology. I think that's a really important piece. And what came forward? And from that, we kind of narrowed down even more to from the 59 down to 9 use cases. The teams worked on 4, and we brought that forward and said, okay, here's like an opportunity for a proof of concept. And that's how we started looking at where do we focus our time. So I encourage you to help educate your peers, your partners, legal risk, compliance, technologist, business, bring those problems forward, and then leverage the knowledge collectively to think about how and where blockchain makes sense for you. Thank you.
Everybody, I'm Jim, one of the co-founders of Kaleido. Welcome. So today I'd like to talk to you about a very important technology, because I'm a software developer, that will be in the future of blockchain. It's called zero knowledge proof. Who have heard of this term? So just as close as like last year or even 2 years ago, this is sort of a fancy term. If you can spell it, you're sort of in a different league. But in the last year or so, this is becoming mainstream. People are getting more comfortable with this, and it's hugely important to the future of Web3. So if you know zero knowledge proof, it involves pretty advanced cryptography. When I took one of our clients through a training session that did not skip any of the math, it took about 2 hours. Don't have the time to do that today, so I'm trying to do a version of 10 minutes and see if we can still get the main points across. Okay, so let's get started. What is zero knowledge proof? The idea is you want to prove to something, somebody something, without letting them know more than what you want to prove itself. So for example, let's go to the next slide. Let's say you're running a kiosk in the state fair. We love to go there, right? So the challenge is you have this picture with thousands of people in it, and one of them is very unique, and its name is called Waldo. And the challenge is, you cover it, and then whoever pays you $5 and say, come and say, I'm going to find it within 30 seconds. You reveal it, and then he has 30 seconds to find it. If they couldn't find it, the next person couldn't find it, 10 people couldn't find it, they start complaining. Maybe Waldo is not there. You're just cheating us. So they challenge you to prove to them that Waldo is really in the picture. So what do? Do you just point and say, hey, look, that's Waldo? You can do that, but then you lose your chance to make any more money because people can just point. They already know where Waldo is. How can you prove to them it's really in the picture without telling them where that is? Okay, so that's one example. If we go to the next slide. Second example, this is a bit contrived, but it's simple enough to allow me to do a prop. So you can experience the zero knowledge proof in real life. Let's say you hire a consultant to design 2 colors for your tournament. Let's say it's a basketball tournament, and you're going to use color balls. And one of your tournaments, like year after year, one of the special thing about your tournament is every time you come up with new color that's never been used before. So every year you have to have 2 unique colors that someone designs it for you. You hire this consultant. She spends a lot of time, let's say, trying to find a unique color is very difficult. So you are at the night before the tournament, you want to check on her work. Tell me you have found those 2 new colors. She said, yep, I've done it. And you want to say, well, I don't want to trust you because last year you left us with only 1 color and our tournament wasn't as fun. How can this person prove to you that she's got 2 colors, but she doesn't want to reveal it to you because it's her IP, right? She doesn't want to reveal this until the opening day. So how does she do that? So let me direct your attention to this prop. Let's say my name is Bob. All of you guys are Alice. You're trying to prove to me that you really have 2 colors with the balls. So I designed the following algorithm. What I do is, so you put those 2 balls there. I'm going to reach in and I'm going to change the position of those 2 balls. Okay, you don't know how I changed that. Now I reveal it to you. I don't see the balls. Like through this whole process, I don't see them. Now I'm asking you, did I change the position from the original position? Okay, maybe you didn't pay attention. Take a look here. Let's try it again. Okay, so I manipulate it without seeing it. Did I change the location? No. Okay, good. That was the right answer. Let's try it again. Do it again. Did I change it? Yes, it did. So that proves to me that if it were 2 same colors, you couldn't have answered that every single time. I try this, let's say 10 times, you answer it the same, the right answer every single time, because I know if I changed it or not. Then I'm pretty convinced there must be 2 different colors. Otherwise, it couldn't have give the right answer. So that's essentially zero knowledge proof. In the process, I give you a set of challenges and you answer the question the right way. And I'm convinced of the fact without knowing more than just that fact itself. So let's go to the next slide. That's what zero knowledge proof comes down to. Knowing just enough without knowing too much. Okay, so let's go to the next. Also, how do we convince Waldo, right? So go to the next one. You just cover it with a big enough canvas with a hole. So you put the picture behind it, and then you just show Waldo. And because it's covered, nobody knows what's the location of Waldo relative to the picture. So you prove that it's there in the picture without telling where in the picture it is. So let's go to the next one. And this was our challenge earlier. Next. So now you kind of concluded that zero knowledge proof is really a probabilistic proof. You are never 100% sure, but if your confidence level goes up to 99.5, it's good enough, right? So it's probabilistic. Next. All right, so let's get a bit deeper. ZK Snark is one of the constructions designed by really smart people to actually make it work with arbitrary problems. So you realize that what we demonstrated earlier with those two different problems is depending on what is the challenge, we're designing different protocols, right? We have one procedure for the two color balls. We have a different procedure for the picture. Can we design a general purpose system that can solve all kinds of problems? And that's what Snark does. So very first step. So by the way, it's sort of a 10-step construction. Every step involves some amount of math. I'm skipping a bunch of them, but hopefully we capture the essence of the construction that at the end of the day, it still makes sense. Very first step is we create circuits. So that is simple enough to do the calculation. Regardless of your problem, at the end of the day, you have to put it into computer. And what does computer do? Computer breaks down big problems into small constructions on the chip, right? It's like adding 0 and 1s and doing multiplications or additions. So computer is great at doing these things, decomposing a big problem into small circuits. So we use a language to express whatever you want to solve. Let's say our challenge today was to find a solution to this formula when the result is 12. It's not easy because when you add a modular thing to this, it's not easy to solve. Let's say you want to prove that you know the answer to this formula when the result comes out at 12. And that's our challenge. I need to prove to you what I know the challenge without telling you what the challenge is. So first thing we do is we break this down into these circuits. And let's go to next. This is sort of what it looks like mentally. It's the bigger problem is decomposed into these very simple steps. Every step is one operator with 2 inputs, 1 output, and you keep doing this until you get what you need. Next. So what we had earlier is now broken down into 4 steps, so that whoever execute these 4 steps using my, let's say, so the answer is, I think the answer is 7. If I plug in 7 and I execute these 4 steps, I get 12. I want to prove to you that I've done all these steps using 7 and I didn't cheat. That's my goal. So the first step is we break these down into these very small steps. And then we use this notion, it's called R1CS, to represent these steps. Don't think too much how that's done, but essentially it's a array of 6 elements that represents the 6 different variables that are encountered in these 4 steps. And they all tell you what is at each step, what is the left input, the right input, and output. So that's what it's trying to do. This is in the first step, this is second step, and the whole matrix represents the entire circuit and the entire calculation. So let's go to the next one. So we have done the first step of sort of breaking down a big problem into very small steps. And then we have a representation of those steps using these matrix. So let's check our work. 3 is one of the answers. That gives you 30, 35, and then you modulo 13, I think you get 12. Let's say 3 is the answer. And this is what's called witness, which is if I plug in my answer to this formula, I get a series of numbers that the calculation gives me. So this is your witness. You keep it private to yourself. You don't tell anybody because this is your secret, right? And then you can plug it into these steps, and then you can check the work. It really checks out that using this formula, you can represent all the calculation. Let's go to next. So that's kind of interesting. Now we have this technique to represent arbitrary computation. It's great. And anybody can check the work using, as long as they have the right witness. The problem is there's no zero knowledge, because you have to disclose to the other person what the numbers are for them to check your work. At the same time, the verifier, whoever's doing verifying, has to do the same amount of work as the prover. So can we do something so that the verifier's job is much simpler than the prover? The prover has to do the whole calculation. Can the verifier use smaller amount of computation to quickly check your work? So that's what we need to do next. We do another transition. Let's go back one. Our goal is to use this construct called polynomial. Polynomial, you probably know that, right? There are two very interesting aspects of this. Number one, it can carry huge amount of information. I'll give you an example next. Second, it's very easy to check if two polynomials are the same. So let's look at an example. This represents that. So let's say I want to prove to you I know all the digits, all the first 35 digits of pi, right? That's a pretty random sequence of numbers. I put it into a polynomial like this. So the power of x continue to increase, and then the coefficient at each position represents my secret. So that ends up being sort of this line here. And let's say if I remember one digit wrong, instead of 8, I remember 9, the curve becomes completely different. What this means is it's very easy to check if you have the right polynomial than I did by just plugging a few x numbers. And if they produce the same y, then it must be the same polynomial. And you don't have to check on all x numbers, just a few random places. If they all give you see even just one digit difference gives you a completely different curve, right? So just use a few x's and you know if we have the same information or not. So that's why we want to convert what we had so far into polynomials. Next. All right, so this step is a bit more complex. It's to have the R1CS notion and turn it around 90 degrees so that we get these polynomials to represent exactly the same information. So if we go to the next one, this series of polynomials give us exactly the same steps that we just went through. So that means these polynomials represent exactly the same kind of circuit and operations we just went through. And this is great because we can now check somebody's work using this. Next step. And I'm giving the signal that time is up. So, but I think this is essentially the last step, that using those polynomials, you can do your verification and you don't have to spend a huge amount of computation, just plugging a few x's and you know your answer. Thanks so much.